The domain of a function refers to the full collection of input values for which the function is defined. In a mapping diagram, the domain is represented by the set where all arrows begin. Each element in the domain is paired with exactly one element in the codomain, showing the functional relationship between inputs and their outputs. A mobile app tracks how much water you drink each day. You input the number of glasses of water, and the app calculates the total liters consumed, assuming each glass holds 0.25 liters. Let the function be defined as an ASC equals 0.25 msin, where min is the number of glasses.
Thank you, my teaching assistant. Before you continue, let me quickly say something. In this particular question, please take a look at it very well. You notice that the number of glasses that you can drink is a whole number. And that whole number starts from what? 1. That is if you drink just only one glass of water. Or 2. Let's say, for instance, you drink 2 glasses of water. But remember that what if you didn't drink anything? That is 0. So you can as well enter a 0 into the mobile app. So which means that the domain contains when you don't drink anything, which is 0. When you drink 1 glass of water, which is 1, when you drink 2 glasses of water, when it's 2, when it's 3, when it's 4, up to when it is plus infinity. Do you notice that? But remember, it's not possible for you to drink a negative number of glasses. Take note of that.
The codomain of a function is the set that contains all potential output values, whether or not they are actually attained by the function. In a mapping diagram, the codomain is where the arrows from the domain terminate. Some elements in the codomain may not have any arrows pointing to them, indicating unused or unmapped output values. A school grading system assigns letter grades based on student scores from 0 to 100. The function g_score returns a letter grade: A for 90 to 100, B for 80-89, C for 70 to 79, D for 60 to 69, F for below 60. Assume the function is defined as g 0, 100, A, B, C, D, F, I, where I stands for incomplete, used in special cases but never assigned through scores. What is the codomain of the function g?
My research assistant, please stop. Let me say something. Now, everybody, please listen. Look at this question very well. You will notice that the codomain for this particular question, it contains A, B, C, D, F, and I. But most times, it's not possible for a student to go for the test and score high. Do you agree with me? It's not possible for a student to go for the test and score high. And remember that high stands for incomplete. So if a student should go for the test and submit, definitely the student will score something, which if the student didn't put anything right, anything good, then the student will score F. So in that case, the codomain will focus on everything in the output, because A could be output, B could be output, C, D, F, and I could be output, but not range.
The range of a function consists of all output values that are actually generated by the function from the inputs in its domain. In a mapping diagram, the range includes only those elements in the codomain that have arrows pointing to them. Since not all codomain elements must be used, the range is always a subset of the codomain.
Oh, I believe you are familiar with this particular question. We've talked about it in the physical classroom. But let me now add something to it. For this particular question now, we are asked that what is the range of the function? And you remember that if you put in -3 into the function, we have 9. When you put in -2 into the function, you have 4. Even when you put 2 in the same function, you have 4 again. So one thing you should notice is that the range is the unique output. Let me say it again. The range for this particular question is the unique output. So you need to only consider 0 once. You need to consider 1 once. You need to consider 4 twice. Knowing fully well that even if you put -2 in the function, you have 4. If you put +2 into the function, you have 4 again. So please, there will never be anything like repetition of 4 twice. So it's going to be once. And remember from the set theory. So which one is the correct answer? Thank you.
A well-defined mapping means that every element in the domain has one and only one corresponding element in the codomain. This ensures that the function behaves consistently and predictably. If any input is assigned to more than one output, the mapping fails to be a function. In visual terms, each arrow must start from a unique domain element and point to a single codomain element to satisfy the function definition. Great. Let us consider the last tutorial question for this video. A coffee machine is programmed to dispense drinks in cup sizes of 100 milliliters, 150 milliliters, 200 milliliters, or 250 milliliters. The software that controls the machine is designed to allow selection from 50 milliliter to 300 milliliters in increments of 50 milliliters. What is the codomain, and what is the range of the function that maps a button press to the actual cup volume dispensed?
Oh, my dear students, now look at this very well. Look at this question now. If you look at it very, you notice that the codomain is the full set of values. And that full set of value is between 50 ml to 300 ml, but in 50 ml increments. Do you agree with me? Yes. Look at the second sentence. The software that controls the machine is designed to allow selection from 50 ml to 300 ml in increment of 50 ml. That is the codomain. But we are not asked codomain. Okay, we are asked that what is the codomain? So that's the codomain. And what about the range? The range is only what the machine can dispense. And it can only dispense 100, 150, 200, or 250 ml. And that will be the range. So pick the correct option. Thank you very much. See you in next video. Bye.